This video explains how to create a calculator that evaluates a given algebraic expression using plus, minus, star, and a slash, and also integers and parentheses using two stacks. I'm going to use two separate stacks. One is the stack of operators, which holds open parentheses and plus, minus, slash, and the star. The other stack is the stack of integers, which only keeps the results, intermediate results, and also the integers that are parsed within that algebraic expression. In order to show you this code, I need to first give you a very simple example of an algebraic expression and two stacks, and I show you what the idea is, what the general idea of the algorithm is. Then I'm going to show you the Java implementation. So let's start by creating a very simple expression, algebraic expression. My expression looks like this. I have 1 plus 1 in parentheses plus 6 divided by 2 in parentheses multiplied by 16 minus 12. And that's pretty much, I should close this parentheses first. And that's pretty much what I'm going to use to show you the implementation or the general idea of implementing a calculator using two stacks. Then I'm going to draw two stacks. One is in a stack of characters holding only the operators star, plus, slash, and minus. And another one is the stack of integers. Also, the open parentheses will be stored in the operator stack. And also, I'm going to have a stack of numbers, stack of integers, which only holds the integers that you see in this expression and also in the intermediate results. Let's start by parsing through this expression. I'm going to go from left to right. And as I go, I will push things into these stacks and pop them once in a while for certain reasons. So let's start by the very first character, which is the open parentheses. I'm going to push this into the stack of operators. Then I see a 1. 1 is going to be pushed into the stack of numbers. Then I see a plus, as you see here, a third character. I'm going to push it into the stack of operator. Then I see 1. I push it into the stack of numbers. Then when I see the close parentheses, that's when we need to do some simplification. So this is how I do the simplification. I remove or pop one element from the operators stack and two elements from the operands stack or numbers stack. And I apply the operator on the two operands. So in this case, 1 is added by 1. And I push the result back into the stack of numbers. So in this case, 1 plus 1 is 2. So I'm going to remove the whole thing and push 2 in it. And also, because this open parentheses at the end is the matching parentheses with the right parentheses I have right now, I'm going to pop that one as well. So after seeing this close parentheses, the stack of operators will be empty, and the stack of numbers will only contain 2. So let's do a little bit of erasing here. I'm going to erase this, this. And I just want to have 2 here. And then now we head to the next part of this expression, which is this plus, right? When I see a plus, I push it into the stack of operators. Then I see an open parentheses, I push it again. Then I see 6, I push it into the stack of numbers. Then I see a slash, I push it into the stack of operators. Then I see 2, I push it into the stack of numbers. Then I see the close parentheses. I'm just going to use green color when I reach to a critical point, and like in this point. Same story as before. When I see the first right parentheses, I need to pop these two, pop this one, and I apply the division of 6/2. The result is 3, and I push it back into the stack of numbers. So 3 is going to be pushed here. And also I will pop this open parentheses because, you know, it matches my close parentheses. So what's going to happen by the end, if I want to maybe erase some of these annotations to make it clearer, I will have a plus only in the operators class, operators stack. And my number stack is made of 2 values. One is 2, which was before, and one is 3 now because 6/2 was 3. So I place 3 here. Then we get to the next value, which is a star. We're gonna, or asterisk. We're gonna push asterisk to the stack of operator. Then we're gonna see an open parentheses. Then we're gonna see 16, which has to be pushed here. Then we're gonna see minus, which has to be pushed here into the stack of operator. Then we're going to see 12, which is going to be pushed into the stack of numbers. And now we're going to see the last close parenthesis. This last one is going to cause a major simplification again. We're going to pop these 2 values, 16 and 12, from top of a stack of numbers. We're going to pop this minus operator. We're going to apply minus on 16 and 12. We subtract 12 from 16, the answer is 4. We're going to push the 4 back into this stack, and we're going to get rid of this open parentheses because that's the matching parentheses of the right one that we saw at the end. So after a little bit of simplification in this annotation, what we're going to have is a 4 on top of the stack of numbers, and also a plus and a star on the stack of operators. So the numbers and stack of numbers are going to be 2, 3, 4. For the operators, we have plus and a star. Similar to the way we simplified things before, we're going to simplify the final values stored in these 2 stacks. How? We're going to pop 2 elements from numbers stack, 1 element from the operator stack. We're going to apply the operator on the 2 operands, in this case 4 times 3. The answer is 12. We push 12 into the stack of numbers, and we're going to get rid of the star because we already have done the multiplication. And then we need to do one last step, which is again, simplifying things. Pop 2 elements from numbers, pop 1 element from the operators. 12 and 2 are going to be popped. And then plus is going to be popped from the stack of operators. We're going to add 12 and 2. The answer is 14. And we're going to push 14 into the stack of numbers. Whatever remains in the stack of numbers, that's the answer, which is going to be 14, which is going to be correct. So that's it. This is an example showing you how the algorithm works with 2 stacks. Now, there is some other details that I skipped intentionally because I didn't want it to confuse you. For example, how does this algorithm take care of the precedence? For example, if it was a star instead of plus here, and if there was a plus instead of a star here, then we should have done the star before the plus, like we should have done this product of these 2 before adding it by the rest, right? So because asterisk or a star has a higher precedence compared to plus, how this algorithm can recognize this precedence and work properly based on the precedence. I will show that in the code, but just to warm you up and give you the idea of how this algorithm works, I should say we're going to ensure that we never push a lower precedence operator or on top of a higher precedence operator. So we never push a plus over a star. Pushing a star over a plus is fine, but not pushing plus over a star. Also, we are not going to push an operator over an operator of the same precedence because both plus and a star are left associative operators. Same for minus and divide. These are also traditionally left associative. So that's how we can handle the precedence and also the associativity of the operators. I'm going to go over the code next. This is a simple Java code. That's enough for all the annotations. I'm not going to use annotations anymore. Let's get into the main method first. This program is basically starts with asking the user to enter a new expression, and then the user enters an expression through keyboard, and then basically in this for loop we are going to parse that expression and calculate it using two stacks. Calculate the result using the two stacks, and we're going to print out the output. As you see, there's a while true here, so we can enter as many expressions as we want in this program. And also, we're going to use two stacks, as I showed you earlier. We have a stack of operators, which only stores characters, plus, minus, slash, star, and open parentheses. And also we have a stack of operands, which is in a stack of integers. That's a stack of numbers that I showed you earlier. It only keeps the numbers, either the intermediate results or the integers existing in the expression. So because we are using stacks, we're going to import Java util. And as you see, there are some methods that are private, and I use them later by the main. So we'll see all the details of those private methods later. But let's get into the detail of the main method. So after the user enters an expression, we're going to store it in EXP. If that expression is done, we're going to break out of the while loop and we're going to end this program. Otherwise, we're going to keep going. What I'm using here is a simple for loop to go over all the characters of this given expression. So for int char from 0, curve less than expression.length, char plus plus, I do this. Let's have a switch over the element at index char. And that switch case is going to have one case for every single possibilities that we're going to have. I'll show you what I mean. So we are going to check if the current character is an open parentheses. If that's the case, we're going to push it to the stack of operator. That was the plan. Otherwise, if it's a plus, minus, star, or slash, we are going to first clean up some elements in the operator and operand stack before pushing that character or the current character into the stack of operators. What do I mean by cleanup? This while loop is going to assure that you never push a plus or minus over a plus, minus, a star, and a slash. Why shouldn't we push a plus or minus over a star and a slash? Because plus and minus have less precedence compared to a star and a slash. Why can't we push a plus and minus over a plus or minus? Because plus and minus have same precedence, and therefore when you want to evaluate back-to-back addition and subtractions, you need to start from left and go to the right gradually. So you need to use left associativity for these operators. And that's why you cannot push an operator over the same, another operator on the stack of operators with the same precedence. Same story for a slash and a star. Star and a slash cannot be pushed over the star and a slash. So this while loop is going to assure that we never push one operator over another operator with the same precedence or with the higher precedence. So we say as long as the operator is not empty, the stack of operator is not empty, and the stack of operators peak is not equal to the open parentheses, do the following. If you compare the precedence of top of a stack of operators with the current character, which is one of the operators, one of the four operators, and that comparison results in the following, that the top of a stack has a higher or the same precedence as the current character, then you're gonna do some simplification. What simplification? We need to pop two elements from the stack of operands and one element from the stack of operators, and we're gonna apply the operator on the two operands using the do up method. Please note that the two operands that we pop from the stack of operands has to be considered as second and first operands respectively. So the first operand that you pop will be the second operand because stack is going to reverse the order. And then the second element that you pop from the stack of operands becomes the first operand of the operator. What does compare precedence do? If you look at the code here, it says basically if you have plus and minus as the first operand and plus and minus in the second operand, they have the same precedence. Otherwise, the precedence of operand one is less, I should say operator. Operator one is less than operator two. Less means negative one. Return value means the operator one has less precedence compared to operator two. If the first operator is not plus and minus, then it's going to be star and slash. Therefore, you need to check the second operator and see if it's plus and minus. If that's the case, then you need to return one because star and slash have higher precedence compared to plus and minus. Otherwise, both operators are going to be star and slash. Therefore, you need to return zero because they have the same precedence. That's the compare precedence that I used. And then do up is very simple. If the operator is plus, then add them. Add the two operands. If it's minus, then subtract them. If it's star, then multiply them. If it's slash, then divide them. Otherwise, return zero. That's the error case that never happens. So I didn't throw any exception. Let's get into the rest of the code. So this simplification assures that these two rules are satisfied. And that's it. I'm going to push the operator that I saw on the expression on the stack to the stack of operators. And then I'm going to break. Break is going to get out of the switch case and start over with the next iteration of the for loop for the next character in the expression. If the current character is close parenthesis, then you're going to have a while loop and you're going to do a major simplification as I showed you in the algorithm. This while loop says, as long as I haven't seen the matching open parentheses for this close parentheses in the stack of operators, keep doing this. First, pop one element from the stack of operators and apply that on the two elements that should be popped from the stack of operands and push the result into the same stack of operands. So what are we doing here? We're going to do two pops from operands, one pop from operators, and one push the stack of operand, which is going to be the intermediate result. And after you finish this while loop, you're going to definitely see an open parentheses in the stack of operators, or you're going to have an error, you're going to have an exception because your parentheses didn't match. There's no balanced set of sequence of parentheses in your expression. That's basically the user's fault. So we don't want to talk about that. Simply in this case, your program is going to crash. I didn't check for that. You can just simply say, if you're not going to get an open parentheses, then throw an exception. Like this way, you can say if the operators dot empty or operators dot peak is not equal to open parentheses, you can just throw an exception, or you can basically, you can just say throw an exception. And then here, let's say unbalanced parentheses. All right, so but I'm going to assume that everything is fine in the user's inputs. Otherwise, the user has to face a crash code. Then after all of this is done, settled down, and everything is taken care of, we're going to care about either the white spaces or the digits in the input expression. If that next character is space or tab, then that means you have white space. Let's just skip them because they're not meaningful. We're just going to remove them. And otherwise, we should expect some digit. Right? So I have a character that is digit method, which is applied on the expression that shall occur, and that's going to see if the next character is a digit. If there's a digit, so that's the beginning of an integer, you're going to use get up to get the whole integer, because an integer can have one or two or more characters or digits. I use the get up to get that character, get the whole integer and store it in the temp. And I'm going to get rid of, I'm just going to skip over all the characters of that integer or all the digits of that integer in the input by doing char plus plus as long as I see a digit. And then this char minus minus is going to undo the last plus plus, because at the end of every for loop, we're going to do a plus plus anyway. So we're going to do this minus minus to cancel out that plus plus at the end. And then I'm going to push that integer into the stack of operands. So when you see an integer, just push it into the stack, and that's it, the stack of operand. And that's pretty much it. One last, and then, if you see any other character other than the ones that I mentioned, you're going to throw another exception saying there's a bad input. One last thing I wanted to mention, I skipped over this line 55 and 56. Not sure if you have noticed it, but the reason I jumped over this is because in some cases, or I should say some rare cases, plus and minus may represent explicit sign. I only allow explicit sign to be entered by the user either at the very beginning of the expression or right after an open parenthesis. If the previous is 0, which is the initial value of previously character initialized to 0, or it's equal to an open parenthesis, then treat your plus and minus like an explicit sign. And in order to do that, you need to push a 0 at the beginning on top of the operands stack. That basically means the plus and minus means 0 plus or 0 minus. That's gonna give you the meaning of explicit sign for an integer. but the limitations exist. You cannot simply say, for example, 2 plus minus 3. That's not allowed here. You need to put this in parentheses. That's how the program can recognize this minus as an explicit sign. So I made it in this way, so it becomes much simpler. All right, so let's clear all the drawings, and this previous is going to be updated after every iteration of the for loop. Right after the switch case, I have said if the character that you're seeing in the last iteration is not white space, update previous and set it equal to the expression that you at car, and that's it. When you're done with this whole for loop, then you're going to do a final simplification on your stack of operators and operands by just popping 2 elements from the stack of operators. I'm sorry, operands, 1 element from the stack of operator, and push the result of doing the operation into the stack of operand. At the very end, line 100, I have printed the result, which is basically the element sitting alone in the stack of operand. So I didn't want it to make this a 100-line program, but that seems to be the case. Gave me a perfect number of lines. Let me run this program with the example I mentioned earlier, so you can see for yourself what the output will be. My example was 1 plus 1 plus 6 over 2. As you see, I generously use spaces just for the sake of readability, and that's it. So let's see the output. The output is 14. For example, if I say -1 plus 2, the answer is 1. So as you see, it recognizes the explicit signs as well. And yeah, that's pretty much it. So thank you for listening.